It says let f of x equals 3x plus 2, and then we're going to graph g of x equals to negative times f of x. All right, we know it's going to be a reflection because if I look at my table here, I'm looking for the negative times the whole function, because when you do that, you're going to change the x-intercept and y-intercept. So that's going to be a reflection across the x-axis. Okay, so we're going to write, what is the transformation? We're going to say reflection across the x-axis. Okay, and how do I know that? Because of the rule. But I'm also going to physically show you how that occurs. Okay, so I'm going to go ahead and graph the original equation. I'm going to graph f of x is equal to 3x plus 2. So my y-intercept is at 2, and my slope is up 3 to the right 1. 3 to the right 1. Or down 3, left 1. Okay, I'm going to go ahead and hopefully draw the best line I can using my laptop there. Okay, so this is f of x. The one in blue is the original f of x equals 3x plus 2. So what it's saying is that you're going to reflect the whole graph across the x-axis. So now I'm going to label my x-axis here just in case you forget where the x-axis is. So I'm going to reflect. Remember like last year when you did reflection, you had to reflect the point across the x-axis or y-axis? That's what we're going to do. We're going to take each point and we're going to find the opposite point that is across the x-axis. So I'm going to go ahead and change it to red, and we're going to do that for each point. I'm going to start with this point right here, the top one that I can see. All right, so I'm going to reflect it across the x-axis. So that's 1, 2, 3, 4, 5 steps away from the x-axis. So on the other side, be 1, 2, 3, 4, and 5. All right, and I'm going to do that for every single one. This one is 2 units away from the axis, so it's going to be 1, 2 on the other side. Now this is already on the bottom or below the x-axis here, so going negative. So we're going to just go up 1 and then 1 to the other side. Down here, it's 1, 2, 3, 4. That means it's going to be 4 on the other side. 1, 2, 3, and 4. The last one I have here is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I'm just reflecting the points across the x-axis. So now I'm going to graph that. Hopefully we draw my straight line. Sorry guys, I don't have a straight line drawing tool when I'm using this, so you guys can see that. Now that's what physically is what's happening. You're just reflecting across the x-axis. But let's go ahead and solve for it and see if it actually is equivalent to that the red line. Okay, so in order for me to get g of x, I have to take f of x and multiply the whole thing by a negative. So f of x is g of x plus 2, so I'm going to take negative and I'll multiply it by 3x plus 2. So I got to distribute that in. So that means g of x is equal to negative 3x minus 2. So let's check to see if that equation matches when we did the reflection, physically reflected across. So my y-intercept is negative 2. Woohoo, b is negative 2, and the slope is down 3 to the right 1. So 1, 2, 3 to the right 1. Or up 1, 2, 3, left 1. 1, 2, 3, left 1. So yes, that graph is the same thing as this red one, which we call g of x equals negative f of x, which is the same thing as me saying g of x equals negative 3x minus 2, because I solved it algebraically there. All right, guys, a couple more videos. I know it's a lot.